Another useful measure of variability is the coefficient of variation. This is to compare dispersion when two data sets have very different variable units, like inches versus centimeters, or if very different means. So basically 50 pounds versus 150 pounds. So for example, maybe I'm comparing weight of soccer players versus weight of football players. The averages are going to be very different. So I might want to just put them on the same level playing field by sort of standardizing the variability and then comparing. So we use the coefficient of variation, CV for short, and we basically just take the standard deviation, divide it by the mean, and make it a percentage. Move the decimal place 2 places. So basically multiply by 100. So just be careful there. It's actually the standard deviation divided by the mean, but often the mean is given first. So sometimes we tend to want to put the mean divided by standard deviation. So let's look at some examples of this. Find the coefficient of variation for prices of these three stocks. Which stock has the greatest relative variation? So basically the one with the greatest relative variation is going to be the one with the highest percentage, the highest CV, the highest coefficient of variation. So when you first look at them, stock A has a mean of $24.50 with a standard deviation of $5.25. Stock B has a mean $147.25 with a standard deviation of $12.25. Right there you can see that there's very different means, $24 versus $147 versus stock C, $5.75. So that's an indication that I wouldn't want to just look at the standard deviation. In fact, just looking at this data, I would say that stock B has the most variability because of that $12. But as we'll see, once we kind of standardize it into this coefficient of variation, that's not the case. So again, the equation is standard deviation divided by the mean and then multiply it by 100 to make it a percentage. So that's just an equation you can, put in an Excel sheet if you would like to. So the reason we don't just compare standard deviation for variability is because you can get the wrong picture here. It's not relative to the mean. So if we look at standard deviation for stock B, it's $12.25. Relative to $147, that might not be that much. Whereas stock C, standard deviation is $2. Relative to the mean of 575, that seems somewhat high. Let's make it a percentage. So here's what we do. Take the standard deviation, divide it by the mean, multiply by 100. So for stock A, we get 21% variability, or relative variation. Stock B, 8%, and stock C, 36%. So in our original data, it almost looked like stock B had the most variability, but once we find the coefficient of variation, we see that stock C actually has the most variability. So our decision is we choose C if we want risk, and choose B if we want to be conservative. So again, I actually like to do coefficient of variation for any data set, but typically when I do it for when two data sets have different units or different means. Okay, so what if we had this question? A lab mouse weighs 18 grams with a standard deviation of 0.9 grams on average, while the lab rat weighs on average 300 grams with standard deviation of 20 grams. So they're in the same units, but notice the means are very different, 18 grams and 300 grams. So compare the dispersion, which animal has more relative variation. You're going to start with the equation. So standard deviation divided by mean. For the mouse, 0.9 divided by 18 times 100 is 5%. For the rat, standard deviation divided by mean is 20 over 300 times 100 is 6.67%. So the rat has more relative variation at 6.67%. And what about the coefficient of variation for the age data that we just looked at? We had the standard deviation of 22.68. The mean was 55.63 years times 100, so that's 40.77% variability. That's kind of a lot compared to some of the other ones that we've seen so far. 36% was the highest for the stock A, B, and C options. And since it's a percent, we can more easily compare it to other data sets. And what would have more variability? Like I mentioned before, age or GPA. For CU freshmen, it's definitely going to be GPA, because most freshmen are around the same age. Okay, so some decisions I would make based on the information in this chapter. I hire more baristas at Starbucks because the average wait time is too long. I choose a stock that has the lowest variability because I want a conservative portfolio. Median home price is too high, so I choose a different location for my manufacturing plant. I don't have a lot of confidence in average sales because the standard deviation was really high, or the average, or the coefficient of variation was very high. Okay, so again, at the end of each slide deck is some Excel functions and tools. Here's where you would go in Excel's data analysis tool pack. It's another Excel add-in, so you can add that in under options. If you have a Mac, it's just under tools and add-ins. And then some of the Excel functions, if you didn't have Megastat or ToolPak at this point, you could still use these functions. You know, just hit equals average and select the data range. It'll give you the average. So not quite as efficient as just getting the whole set of descriptive statistics, but we do definitely have those functions out there. For standard deviation and variance, it's .s for sample. You would put .p if you had the whole population, but that's pretty rare.